Thank you, Colin. You caught me by surprise with the quick ending there. We'll now move into the project presentations, and I'll ask the projects, please, to stick to the time limits. We do have lots of projects to show, and I think there is probably too much information. So when you're giving your presentations, please, yes, explain your project, but don't go into too much detail. Allow them to read some of the details off the slides later. Our first project in what is more or less alphabetical order, even though we don't know how an exclamation mark counts in the alphabet, 5G drones. And can I ask Jussi Haapola to, how do I pronounce it? Haapola. Okay. Jussi, please. There's a remote there.
Okay. Thank you. So 5G drones, as the project says, is all about drones. So every single use case we have is related to a UAV or UAS vertical system. So the project, we have about 20, or we have exactly 20 partners. So it's quite well balanced between 5G companies, between UAV companies, and the academy as well. So we have a few challenges in here. So the UAV industry is kind of just a fledgling industry. It's growing, it has a lot of potential. But one of the main limitations is that the reliable flights, especially beyond visual line of sight, is kind of difficult. Most of the UAVs, they actually can focus on using proprietary radio solutions that, okay, you get connectivity a few kilometers, but it's sort of limited in what you can transfer, how good imaging you can transfer, etc. And that suddenly it stops. So the point of 5G is to enable these reliable flights beyond visual line of sight, and that has been recently enabled by different regulatory changes. There are technological advancements, and of course the drones have better onboard control units and better possibilities as well. So to enable the adoption of UAVs, basically we need ultra reliable and low latency remote command and control communications. So this is where 5G can help the UAV industry significantly. It's really, if you can create slices that are secure, they guarantee you a very low latency, and it works well over tens of kilometers of distances. I think it's a very good start. So integrating 5G and UAV has positive sides for both of the parties. So for it's beneficial for the UAV verticals because they will be able to validate their use cases and demonstrate the benefit of the huge potential that UAV carries in civilian and commercial applications. They also enable the reduction of the maintenance cost because they don't have to actually take care of the communication network. And it will streamline their risk assessment because the current regulations state that you have to carry out very, very, very detailed risk assessment whenever you're doing flights. Whenever you're rising above 50 meters, whenever you're going beyond visual line of sight, it is a very lengthy process, and this will make it so much better or so much easier. So for the 5G actors, the UAVs present an interesting space because the drones will be flying high, well, at least, well, easily 50 meters, maybe 100 meters, in some cases kilometers. And we all know that the base stations are not aligned to cater for services at that altitudes. And of course, any transmissions coming from UAVs, they tend to interfere quite heavily with multiple cells because you have free space path loss, the transmission distances covers like multiple base stations at a time. So the main targets for this project, so we trial several use cases that cover eMBB, URLLC, and massive machine type 5G services. So one of the key concepts, well actually one of the main key concepts is network slicing in here, because we need to run different applications. We need to run a UAV management slice, which is completely isolated from the data that actually takes place in UAV communications. And we have to do it end to end. So we have to include run, backhaul, core, etc., etc. So specific challenges. So these are the things we need to answer. Questions, a lot of questions. What are the missing components in current ICT facilities? So we're using 5G EVE in Sofia Antipolis. We are using 5Genesis in Athens. We're also using the 5GTN network in Oulu and the AltoX network. So what are the missing components to support UAV verticals use cases? What current 5G components need to be improved? How do we allow the UAV verticals to run the test without somebody in the 5G domain typing in the specific inputs required for a particular UAV use case? So how do we automate the process? That's a significant test. So that relates to also to abstraction of the ICT-19 facilities and their APIs. And really how to build a secure network slice, which is completely isolated in some cases. Imagine, for example, a drone flying over a stadium with tens of thousands of people. It is simply not acceptable that the drone crashes down. So we have to guarantee that the control is perfectly secure. Nobody can interfere. You have to be able to predict if there are any possible ailments to the operation of the UAV, and you have to divert it. So that requires significant security. So the division of work is like this. So on the left side, we have our basic architecture. So we have the 5G facilities, and we have the end-to-end slices. So these are governed by the southbound API. On the other hand, on the up, we have the UAV verticals, and they access the facilities via web portal through the northbound API. But what then? We actually need to implement a trial engine. So that is the coordinator for the different trial use cases. We need to implement strategies and also functions to monitor the KPIs, not only the 5G KPIs, but also the UAV KPIs. And we need to enforce the trials. So whenever a trial is created, it needs to be instantiated in the 5G facilities, and they need to be enforced. So on the right side of this figure is how we're planning to do it. So it's a description of the work packages we have. So first is work package 1, which is use cases, which is already started. And basically it covers the use cases and system architecture. So how and what the UAV, so what are the actual exact scenarios that cover what the UAV industry needs, because oftentimes UAV industry has a lot of several kilometers of flight. And we all know that the current ICT-19 facilities or any other 5G facilities, they cover very limited distances. So how to be able to demonstrate the key UAV KPIs within those facilities, how to transition from the facility into a normal network and come back and still satisfy the use case, and also how to assess the 5G KPIs. So next I would have the objectives for this project, but I'm going to skip them because it's homework for you. What I want to show is really two objectives that we have on validation of 5G KPIs So we have the URLLC, and I really emphasize the ultra reliability here. That is our key concern. Also, the latency is in some cases less than 1 millisecond is really, really, really challenging, but we need it for UAV traffic management. So the other side of the coin is to also validate the UAV KPIs using 5G technology. So you have a number of topics in there. And here's our consortium. So 20 partners from many countries. We have, from the UAV side, we have UAV software manufacturers, UAV drone, so drone manufacturers, air traffic management software providers. We have consulting in the UAV domain as well. So we have the entire UAV sector. Also, we have a slightly bigger UAV, operator called Airbus. On the other hand, we have on telecom side, we have significant players. We have Nokia. We have, on the security side, we have Thales Communications. And, of course, as Bernard Parani showed, many of the academic institutions that are in the top 10. So, thank you. This is our social media. Please follow us.